In this demo, we will be measuring a rubber conveyor belt sample that includes steel cord reinforcement. We will measure the total thickness of the sample, which is 0.870 inches thick, or if you are using metric units, it would be 22.1 millimeters. We will also measure the distance to the steel cords, which is 0.365 inches, or if you are using metric units, it would be 9.27 millimeters. We will be using an Olympus 38DL Plus thickness gauge. The exact key presses would be different if you were using a different model Olympus thickness gauge, but the overall process would be the same. We are going to use the 2.25 MHz M1036 direct contact transducer. The first step would be to connect the transducer and plug the transducer cable into the TR1 at the top of the instrument. Then turn the instrument on. Once the instrument is on, press the XDCR recall key. Since we are using a 2.25 MHz transducer, we will press the down arrow to default single element and then press Enter. Here you will see the list of default single element transducer setups. Press the down arrow to highlight DEF M1-2.25-M1036. At this point, you can press the red Measure key to recall the setup or press the Enter key to see the parameters within the setup. If you press Enter, press the red Measure key next in order to recall the setup and return to the measurement screen. The default setup we recalled has a default sound velocity for stainless steel, so we need to change it to something closer to rubber. To do this, press and release the second F key first, and then press the yellow Cal-Vel key. The stainless steel velocity is shown on screen. Use the arrow keys to change this value to the approximate sound velocity for rubber, which is 0.063 inches per microsecond, or if you are using metric units, it will be 1.600 millimeters per microsecond. Then press the red Measure key. Next, we will need to change our range. Currently, the range is set to ½ an inch. If you are using metric units, it will be set to 10.0 millimeters. Given the total thickness of our sample, we will not be able to see the back wall echo on screen since the range is currently set too low. To change the range, press the blue Range key until the bottom right side of the screen displays 1.00. If you are using metric units, press the Range key until the bottom right side of the screen displays 50.0. Now, since we changed the velocity to be close to rubber and we adjusted our range appropriately, we have a rough idea of where the back wall echo should appear. Given the thickness of the part, the total thickness back wall echo should appear to the right of the center of the screen when using imperial units. If you are using metric units, the total thickness back wall echo would appear towards the middle of the screen. We can now apply couplant to the part and couple the transducer onto the sample in a spot between the steel cords. We start to get a reading which looks to be correct. The signal appears on screen where we would expect, and the thickness reading is close to what it should be. Take note of the polarity of the signal. Since the sample is backed by air, the echo polarity is negative, since rubber interfacing with air represents a high to low impedance relationship. We will now try to measure the distance to the steel cord reinforcement. The signal from the steel cords should appear positive, since rubber interfacing with steel represents a low to high impedance relationship. Therefore, we need to change the echo detection to positive. To do this, press the Wave Adjust key. This will bring up the setup parameters at the bottom of the screen. Press the down arrow to Echo 1 detect. Then press the right arrow to change it to positive slope. Since the distance to the steel cords is less than the total thickness, the signal should appear sooner in time. We can now apply couplant to a spot on the sample above one of the steel cord reinforcements and couple the transducer onto the sample. The instrument is still measuring total thickness. This is due to the diameter of the transducer being larger than the diameter of the steel cords. Since the signal from the steel cord appears sooner in time, we need to increase the initial gain. To do this, press the up arrow to INIT gain, then press the right arrow to increase the initial gain. Keep pressing the right arrow until the signal from the steel cord is being detected. We are now making detection of what appears to be the correct signal. The signal appears sooner in time, and although the signal is irregular due to the contour of the steel cords, it does appear positive as we would expect. We can now check the other areas of the sample that include steel cords to make sure the signals are detectable. This steel cord is able to be detected. However, this signal is still too low in amplitude to be detected. Since this signal appears under the slanted portion of the gain line, we will increase the TDG slope slightly. To do this, press the down arrow to TDG slope, then press the right arrow a few times until the signal is being detected. At this point, we should be able to scan the transducer across the conveyor belt sample and see where there are steel cords and where there are no steel cords. It is important to remember that the polarity of the signal changes when measuring to the steel cord versus when measuring total thickness. Therefore, the user will either need to change the echo 1 detection depending on the measurement, or if they would prefer, they could save 2 separate custom setups. Also, if the customer is only interested in measuring the distance to the steel cords and does not want to measure total thickness, they could decrease the echo window to prevent the instrument from detecting the total thickness echo. To do this, press the down arrow to echo window, then press the left arrow to decrease the echo window until it is set right before the occurrence of the total thickness echo. This adjustment takes some time, since the default echo window for the M1036 transducer is set large. This is because the M1036 is a 2.25 MHz direct contact transducer, which gives it great penetration capabilities. Once the echo window is reduced so that it does not include the total thickness backwall echo, when we scan the part, we will only get a reading from the steel cords. As always, once the correct echoes are being detected and the thickness readings are close to what they should be, the next step would be to calibrate using samples of known thickness of the same material you are measuring and then save the transducer setup.